Good afternoon, everyone. Welcome to week 2. Let us wait for some time till other people join. We will begin in about a few minutes. Okay, now some of you have joined. I'm not so well today, so pardon me if my voice is not sounding as great as it was earlier. I seem to have caught a bit of cold and cough and slight fever, but I will still try my best to do this session. So in this week we were introduced to the concept of sets. So how to define a set, what are the notation used for writing a set and its elements, Then what are the operations possible on set? So if you have two sets, you can have union, intersection, or difference. And then what are the identities and laws involving those sets? So we saw like De Morgan's laws, distributive property, associative, commutative, all these properties and identities we saw. So this week the questions are also then based on sets. So let us start with the first question. Okay, so for those of you who are joining for the first time, I will share the details about this course. So this is the NPTEL course on calculus for economics, commerce and management. And it is 8 weeks long course, and every week you will have to submit one assignment which will be MCQ type questions. And here every week we will have these live problem solving sessions. In which we will look at some simple examples and problems which will eventually help you in solving your assignment problems. So these questions are from the past year and they will help you in answering questions from the current year. And these sessions will be conducted over Zoom on the same Zoom link from 3 p.m. to 5 p.m. every Saturday. And they will also be live streamed on the YouTube channel. The link I will put in the chat box right now. Okay, so that's the link. It is my YouTube channel and you can go ahead and watch the live stream over there and even watch the previous week's videos. And if you want these notes, they will also be uploaded and you can download it from the link given on the NPTEL course website. Okay, so we will start. I'm really sorry I'm not able to speak properly today. I'm not keeping well, but we will still try to have this class. So this is the first question. You are given 3 sets A, B and C and the elements of the sets are written. So recall that elements of a set are given by these curly braces, inside these curly braces, and ordering of the elements does not matter, and elements are not supposed to be repeated, they are supposed to be written once. So these are the 3 sets. Which of the following statements is true? So I will launch the poll for this question. You will see a poll in your Zoom window. So please select the correct option in the poll. Do not send me the answers on chat box. Please select it on the poll itself. So the questions for this week are like very simple. So please try to attempt the poll. Take a few minutes and then we will discuss. Okay, so let us now discuss the solution. So the correct option is option B. This question is about being subsets. So this symbol denotes subset, and this denotes subset or equal to. This bottom horizontal line is either subset or equal to. So we can clearly see that A is a subset of C. Why? Because let us highlight the elements. So A has these 5 elements, and C also has those same 5 elements as A plus additional elements. So these are the additional elements that C has. So clearly C has all the elements of A plus additional elements. So A is a subset of C. Now B is not a subset of C because B has this element over here 0, which is not present in C. So 0 is an element. This symbol over here means element. 0 is an element of B, but 0 is not an element of C. This with a line crossing it means not element. And we can also see that A is a proper subset of C because A is not equal to C. This is because A and C are not equal. So not just A is subset equals C, it is actually a proper subset. So this is the correct option. A is subset of C, option B. So this completes question 1. I hope there are no doubts anymore. If you have any question at any point of time, please feel free to put it up in the chat box, or you can even unmute yourself and ask. Okay, someone is asking what is this epsilon symbol. This means it is an element of, or it belongs to. So 0 is an element of B, or 0 belongs to the set B is denoted by this symbol over here. Also, it is a good idea to watch the videos before attending these problem solving sessions. That way you will be better prepared to understand the concepts and solve the problems. Okay, so I think we can proceed further to the next question. So now we move to the next question. Which one of the following sets does one not belong to? Notice that this is not belong to, and it's not like does one belong to. So, and these are the options. These are like some intervals which are also sets containing real numbers. So options are square brackets 1 2, then left square bracket 1 and right parenthesis for 2, then left parenthesis for 1 and right square brackets for 2, and then 0 to 2 parenthesis. So as usual, I will relaunch the poll and then please take some time to analyze and solve. These are like very simple basic questions for sets. Means you would have studied these topics in your class 11th and 12th as well. So these are like basically school level stuff. So if you have studied, then it is like a revision for you. If you have forgotten, then now is the time to have a look at it. And if not, then these are like simple topics and they have been discussed in the video lectures for the course as well. So you will be able to understand and grasp the concepts. Pardon me. Okay, let us now discuss the solution. The correct option is option C. I see that some of you have selected the other options because you probably did not read this word not over here. It is very important to read the question properly. So the question is, which one of the following sets does one not belong to? And it is not which one of the following does which one of the following sets does one belong to. That is a different question. If that would have been the questions, then A, B, D, any of these options would be correct. So now how do we come to this? This is like by definition, meaning I'm really sorry, I'm not keeping well, so my voice is not sounding nice. So this is parenthesis denotes open bracket, which means that the particular number is exclusive, means it is excluded, and this means closed bracket, so it is inclusive, meaning that particular number is included. Now if you have an interval something like this, of course you can have all the other options, both square brackets, both parentheses, left one parenthesis or right one parenthesis. You can have all these options. But let's take an example. So this interval or set basically means it is the set of real numbers, so elements x belonging to R, such that x is larger than A and is less than equal to B. That is the meaning. So had this left bracket been a square bracket instead of parenthesis, then you would have added an equal to sign here also, but right now it is parenthesis, so it's like that. And if the right one would have been a parenthesis, then you would have removed this equal to, but right now it is square, so that's why that equal to. So that's the meaning of this interval. So clearly you can see that this is a square bracket, so 1 is included. This is also a square bracket, so 1 is included. In this both are parentheses, but within 0 and 2 1 will lie somewhere in the middle. So it is not at the end point, but it is safely somewhere in the middle, in fact exactly in the middle. So it is within that set, it is within the limit, within the extent of this interval. So that's how 1 is present in all the other 3 options, in all the other 3 sets, but it is not present in the option C. So this completes question number 2 as well. Moving on to the next question. Another question on intervals as sets. Which among the following sets is equal to R minus the interval 0, 1, both having square brackets? So you can have a look at the previous question as well, where I defined how to understand what intervals are and what the square and parenthesis mean. So what these brackets denote and how to write the intervals. You can have a look at the previous question once and then move ahead. So I have relaunched the poll. Some people are still putting in the chat box. I sincerely request so I request that please don't put in the chat box. Please put it in the poll itself. So the poll is actually anonymous. So other people, and even I don't get to know who has answered what option. So that creates transparency. But in the chat box, people get influenced based on what other people are answering. So let us now discuss the solution. So in case you have not seen this, so this symbol right here, this means difference. And the brackets I explained over here. So parenthesis means open bracket, that means the element is excluded, and square brackets means closed brackets, so the element is included. And this is one particular example of the interval and how it is denoted. Now if I were to draw, let's say, a Venn diagram and show what difference means. So if this is, let's say, one set, and this is, let's say, another set. So let's call this B, let's call this A. So when we look at A minus B, that means all elements of A which are not present in B. So that would mean this particular region that I am shading. So this is A minus B. So the entire A will be this blue circle, means this, sorry, entire A is this blue, entire blue. Out of that we are removing elements which are there in B. So the B is this green. So elements in green we are removing from elements of blue. So that gives us with this red shaded region. So that is A minus B. Now R denotes real numbers, set of real numbers. Now from real numbers we are removing this interval 0 to 1, both the elements are included. So that means if I were to draw a number line, let's say, if this is my number line and let's say this over here is 0, this here is 1, this is 2, and so on and so forth till infinity. This is minus 1, minus 2, and so on and so forth till minus infinity. So this is plus infinity here, this is minus infinity here. Now from this set of real numbers, this number line is the real numbers, we are removing this part 0 to 1, both of them included. So what are we left with? We are left with this minus infinity to 0 and then 1 to infinity, and so 0 and 1 are not included. So this green part is actually R minus the interval 0, 1. So what is that equal to? That is option A. From negative infinity to 0, 0 not being included, that's why this parenthesis, and then 1 to infinity, 1 not being included, so this parenthesis. Why? Because we are subtracting these square brackets, that means 0, 1 included, that those elements we are subtracting. So I hope this question is clear. If there are any doubts, please feel free to ask at this point. Okay, someone is asking a very nice question. Why infinity is in parenthesis and not square brackets? So, infinity or negative infinity is always written in parenthesis because it is not a fixed number, right? Infinity, you cannot define infinity as such. It just goes on and on and on and keeps going on, like as big, as big, as big, and it's not a fixed number, it's not a fixed quantity. It's a mathematical abstract quantity to denote that we are going on and on and on. We are not stopping anywhere. So that's why, by definition and convention, and by the mathematical abstract quantity defined as infinity, it is always in parenthesis. So that's a good question. You cannot pinpoint the location infinity on this number line, right? You cannot pinpoint, okay, this is infinity. So as a result, it is denoted only in parenthesis. Okay, good question. So we can proceed further now. So the next question. So this week we saw sets and then we also saw sequences, the different kinds of sequences that can be made. So here is one example on sequences. Let me read it out for you. A boy tries to write a sequence A1, A2, A3 and so on and so forth as follows. The first term is A1, which is taken as 2. If the last term written currently is a multiple of 2, that is, it is an even number, then he adds 1 to it to get the next term. If the last term written currently is not a multiple of 2, that is, it is an odd number, then he adds minus 1 to it to get the next term. And in this particular form, the question is, what is A5 equal to? A5 meaning the fifth term. And these are the options 0, 1, -1 and 2. So again, take some time to answer this question and select the option which you think is correct in the poll. Okay, so let us now discuss the solution. A1 equals 2. This is the first term given to us. And clearly this is a multiple of 2. That means even. So what we will do? We will add 1. This is what is given over here. If it is a multiple of 2, then add 1. So when we add 1 to 2, then we get the next term. This will become 2 plus 1 equals 3. Now this is odd number. That means not a multiple of 2. So what do? We add negative 1. This is what is given, that if it is odd number, then add minus 1. So the next term will then be 3 minus 1, which is once again 2. So this is even number. So what do? We add 1. This gives me the fourth element, which is 2 plus 1, 3. And this is again odd number. So we add negative 1 to it. This finally gives us the fifth element. 3 minus 1 equals 2. This is the fifth element that we wanted to find out, and so this is equal to option D. So this is a sequence which keeps alternating between 2 and 3. So it's basically a sequence which goes like 2, 3, then 2, then 3, then 2, and then 3, and it just continues in this particular manner. So you see that every odd element of the sequence, that is A1, A3, A5 is 2, and every even element, that is A2, A4, A6 and so on, is 3. So basically you can write it as An is equal to 2 if n is odd, and 3 if n is even, and n basically belongs to natural numbers. So this was the solution. Pretty straightforward, just like almost all the questions in this particular week. They are pretty much straightforward and basic, just beginner level to build up for the future lectures and for the upcoming weeks. So this is, you can just say, like a warm-up exercise, just to build the core foundation and the notation that will be used further on. So that was for question number 4. Now we can proceed further to the next question, which is question number 5. I hope there are no questions. Let me check both the Zoom chat and the YouTube chat. So some people who face connectivity issues in Zoom, they actually join the YouTube live stream, and there also you can post the questions in the YouTube live chat. Okay, it seems it's all clear, so we can proceed. Which of the following is the method of representing sets? There are 4 options: sequence method, roster method, bracket method, or list method. So the correct option over here is option B, roster method. So in roster method, the elements of the set are explicitly listed out. For example, in roster method, let's say we have a set A and the elements can be listed out explicitly as follows. There is another method which is known as the rule method or some other synonyms of it, but what it basically means is that instead of explicitly listing out the elements, you provide with a rule which gives those elements. So here the rule can be x which belongs to natural numbers such that x is even and x is less than 10. So all even natural numbers less than 10, that will be 2, 4, 6 and 8. So these are the two ways of denoting representing sets, and they are exact same, meaning the elements will be the same whether you explicitly write the elements or you provide with a rule. It is the same set. So we are now halfway through. There are 10 questions and now the questions will be like true and false type. So the polls that I will launch will also be like true false. So the first 5 questions were like multiple choice questions, meaning 4 options were there, you had to select one option. So 5 MCQs and then now you have 5 true false type questions. So even in your assignments and in your exam, you will see like a mix of both MCQs and true false type questions. So we can proceed now to the next question. So the question is, we know that the symbol phi denotes the empty set. State whether true or false phi belongs to phi. It's true or false. You need to select. Very simple, means it's just by the definition of what is an empty set. Okay, so the correct option is option B, false, because by definition empty set cannot have any element. So if what this means is, like, you have an empty set. This is what is empty set, means it has no element. So there is no element which belongs to the empty set. So this symbol means belongs to. So if you have an empty set, then there is no possible element which is a member of the empty set. Now if you have a set which is like this, let's say this, then this is not an empty set, because this is a set which contains the empty set. The cardinality for this set will be 1. It has one element which just happens to be the empty set. So this set contains a set in itself which is the empty set. So that's why this is not the same as empty set, because empty set you cannot have any elements. That is just by the definition of an empty set. Now I mentioned cardinality. Cardinality means number of elements in the set. So empty set cardinality is 0. No element, meaning cardinality is 0. And why I am talking about this cardinality and number of elements? Because the next question is based on that. The next question is based on cardinality and number of elements. So I hope this is clear to all, that empty set is just as the name suggests, it is empty, it has no elements. Next question, another true false type. State whether true or false. For two finite sets A and B, if n A union B equals NA plus NB, then NA intersection B is 0. N means cardinality. So I will launch the true false type poll. Please select either true or false in the poll. Okay, so now time for the answer. The answer to this one is true. And why? Because the expression is as follows. So clearly, if NA union B equals NA plus NB, then this term will be 0. And I can draw some Venn diagram to just illustrate. And first of all, as mentioned earlier, N is over here. This denotes cardinality of the set. Cardinality of the set means number of elements in the set. Now let me again draw a Venn diagram. This is, let's say, set A, and this is, let's say, set B. We saw a Venn diagram in one of the earlier questions over here. So this diagram is what is known as a Venn diagram. It's just a pictorial representation of sets. So here is another Venn diagram. Now all the elements of A are this blue circle. All the elements inside this blue are all the elements of A. So that will be NA. Now for NB, all the elements in B will be in all the elements inside this green circle. So this is NB. Now A union B is this entire set. So A union B basically is this entire thing. So that is, maybe I can shade all elements of A union B. This is the entire A union B. The red curve is A union B, that denotes A union B. Now clearly you can see, if you add the blue region and the green region, then there is one common region, this region over here, which I shaded just now. So this region is actually common, and this will be repeated 2 times if we do add the elements from number of elements from A and number of elements from B. If we take both of them, then this shaded region will be counted twice. It is part of A also, it is part of B also. In fact, this shaded region is basically A intersection B. So this shaded region will be counted twice, which we do not want, and hence number of elements in A union B is actually number of elements in A plus number of elements in B minus number of elements in A intersection B, because we do not want to count this twice, we want to count it only once. So this was just a pictorial way of showing this expression. How A union B is, cardinality of that is cardinality of A plus cardinality of B minus cardinality of A intersection B. Now if the intersection is 0, that means you have the set A over here and the set B over here. There is no overlap, there is no overlapping region between them. So here you can easily see, then it will be just the number of elements of A plus number of elements of B, because there is no intersection whatsoever. So I hope this is clear, and we can now move further to the next question. Okay, before that, someone is asking a question of the case A is a subset of B. If that is the case, then the Venn diagram for that will be, so we have this bigger set B and then A will be like a subset of B. So this is how you would represent it on the Venn diagram for A subset B, where A is denoted in this blue and B is denoted in green. Okay, good. Good to see that people are having questions and doubts. Now we can move to the next question. Next question is, state whether true or false. For x comma y belonging to R, if mod of x plus y equals mod x plus mod y, then x equals y. We need to state whether this will be true or false. So take a few minutes to think about this. Okay, so let us now discuss. So this is also true. Oh, sorry, let me change the color of the pen. And this is also true. So what we actually have, this is based on triangle inequality. This is the statement of the triangle inequality, which says that modulus of x plus y is less than or equal to modulus of x plus modulus of y. Now the condition we are given is that if x equals y, then clearly mod of x plus y is mod of 2x, which is twice of mod of x, and this is basically mod of x plus mod of x, which is mod of x plus mod of y, because x equals y. So this statement is true, that if mod x plus y equals mod x plus mod y, then x, one possible situation is that x is equal to y. But this is only one possible situation. This is only one possible situation. There are other situations in which this statement can actually be true, and that is if x and y both are greater than or equal to 0, that is both are positive, then also you will have mod of x plus y equals mod of x plus mod of y. Similarly, when both of them are less than equal to 0, that is negative, then also you are going to have this expression. That means if the sign of both x and y are the same, then mod of x plus y equals mod x plus mod y. However, if the sign of x and y are different, like one is positive, the other one is negative, then it will be less than or equal to mod x plus mod y. So mod of x plus y is less than mod x plus mod y when the signs are when the signs of x and y are different, and when the signs are same for x and y, then it is actually equal. That means mod x plus mod of x plus y equals mod x plus mod y when the sign of both x and y are equal. Like simple example can be, if x equals 2, y equals 3, then mod of x plus y is 2 plus 3, which is 5, which is same as mod of 2 plus mod of 3. If it is both negative, that means x equals negative 1, y equals negative 5, then you have mod of minus 1 minus 5, which is 6, which is same as mod of negative 1 plus mod of negative 5. Now if one is positive and the other one is negative, let's say x equals 6, y equals negative 4, then what you have is, and this is less than over here. So just some simple examples I have shown. Which are examples of this triangle inequality. Okay, someone is saying my screen is appearing blurred. So is it the same for everyone, or is it just for like one person? If you could put it up in the chat box if you are able to see my screen properly. Okay, it seems like it's just for 1%. So I would uh so I would recommend that if you are facing issues in connectivity and blurriness and stuff like that, please watch it over on YouTube. Okay, so if you are facing any technical issues, please watch it over on YouTube. I checked it on YouTube. On YouTube, the live stream is coming out fine. No issues over there. Okay, so we can proceed further. Okay, moving on to the next question, the penultimate question. We have two more questions. State whether true or false there are finitely many rational numbers in the interval 0 to 1. Okay, so the answer to this one is false, of course. There are infinite rational numbers in any given interval, not just in the interval 0 to 1. You take any interval, and there will be infinitely many rational numbers within them. So rational numbers are like fractions or decimal numbers. Rationals are basically given like p over q, q not equal to 0. And you can also denote them in decimals, but decimals should not be recurring. It needs to be finite decimals, means finite decimal places, but this will give you infinitely many rational numbers. There is no limit to the number of fractions that you can have in any given interval, no matter how small that interval is. Okay, so this one was super trivial, and then we have one last question for today. State whether true or false. For a subset of R, A is an interval if and only if R minus A is an interval. So this is the last question for today, and one last time I will launch the true false poll, and then we will wind up for the day. Okay, so the last question, the answer is, of course, false. I mean, for a to be an interval, r minus a is an interval. That is not a condition. A can be an interval in itself. So we have seen intervals earlier, like over here in questions 2 and 3. So these are like examples of intervals. So the thing is, like, if a is an interval, then r minus a is also an interval. But it is not a necessary condition, meaning a is interval implies r minus a is interval, and also the other way around. So r minus a is interval means a is interval. But it is not a condition that for a to be an interval, r minus a has to be an interval. That is not a condition. That is not the proper condition. So if and only if means that a is an interval if r minus a is an interval, and also the other way around. That is, r minus a is an interval if a is an interval. If is the wrong word over here. It basically means it implies, like, a is an interval, then it implies that r minus a is an interval. So that is all for this week and for today. We will move into the next week where we will see more about sequences. Okay, so that is all from my end for today. So in today we just saw like some basic questions for sets and intervals. We also saw like some examples of Venn diagrams, a simple sequence, and like some properties like triangle inequality and for cardinality. So these were the questions that we have discussed and looked at today. So next week we will meet again Saturday 3 p.m. So all our weekly sessions will be held on Saturday itself, Saturday 3 p.m. to 5 p.m. over the same Zoom link. Okay, bye bye. So if you have no further doubts or queries, you can feel free to leave the Zoom meeting. The class is officially over from my end. Okay, someone is asking about books for this. So this is pretty basic. You will get it in like any, you can actually look at NCERT class 12. Like that's, I think, the most basic to start. And any introductory text in mathematics, mathematical methods, they will have discussion on set theory as well. So yeah, I mean, for starters, you can probably look at class 12th NCERT. That will just brush up all your concepts. Okay, bye everyone. Thank you.